This is Jahangeer Soomro, Assistant Professor, Electrical Engineering Department, Sakravi University. This is the third video for the course of LabVIEW Core 1. Before watching this third video, you are requested to please watch first two videos on LabVIEW Core 1. So, in our video of part 1 LabVIEW Core 1, lesson 1, I have already discussed front panel, but I will quickly revise front panel. Front panel is where you can select your inputs and outputs. In LabVIEW language, inputs are called controls and outputs are called indicators. So front panel has a palette. That palette is called controls palette. So when I open this front panel, when I right click it, I get this palette. This palette is called controls palette. So this control palettes can help users to select indicators and controls. So you can select inputs and outputs from this controls palette of front panel. As I already discussed that controls are interactive inputs and indicators are interactive outputs. So as I already discussed in my first part of LabVIEW Core 1, Lesson 1, that there are three types of controls and indicators, or there are three types of data types in LabVIEW. One is numeric. So numeric control and indicators are basically used for displaying or writing numbers such as integer or real numbers. So numeric data type can represent numbers. This is numeric control to write or to enter any integer or real number, and this is the numeric indicator to display the number. In other data type is Boolean. Boolean data type has two possible states such as true or false or on or off. This vertical or toggle switch is Boolean control. This can be either on or off, and this is Boolean indicator to display either the LED is on or the LED is off. So the third data type is string. String data type is sequence of ASCII characters. You should use string controls to receive text from the user such as password or username. So this is string control where user can enter ASCII characters, and this is string indicator that is showing the ASCII characters that user has written. Now we start our next topic, and that is block diagram. Now basically in block diagram we are going to study block diagram toolbar, components of block diagram, express VIs, node appearance, wires, context help and LabVIEW help, and then finally examples. Alright. Now basically block diagram is a window that contains graphical source code. Now this is a front panel where the user can select inputs and outputs. And when I press Ctrl E, I get this window. That window is called block diagram. In this block diagram, user can write its graphical source code. User can write its algorithm. What operation user wants to apply on this front panel, inputs and outputs, that algorithm that is written in block diagram. So block diagram basically consists of different components. Block diagram objects include terminals, sub-VIs, functions, constants, structures, express VIs, and wires, which transfer data among other block diagram objects. This red highlighted portion is called block diagram toolbar. It can be used for execution purpose to run a program. It can be used for debugging purpose. We will study debugging in detail in our coming lesson, and you can also edit your code by using this block diagram toolbar. Now I would discuss various components of a block diagram, and I would discuss and define every component of a block diagram. All right. So block diagram has one component that are called terminals. So what are terminals? Basically, front panel objects appear as terminals on the block diagram. So say suppose this is my numeric control. Now this is a front panel object, but when I double click it, you see it takes me to the block diagram, and here I see terminal. So I again repeat, front panel objects appear as terminals on the block diagram. So this is my terminal on block diagram. This is the terminal on the block diagram. So these are called terminals on the block diagram. There are two types of terminals on the block diagram. One is the control terminals, like these are the controls, inputs. So these terminals on the block diagram are called control terminals, and interactive outputs are indicators. These are the outputs. These are called indicator terminals on the block diagram. All right. So see here, this is a block diagram window. These two are the inputs or controls, and this is the indicator or output. Now these are the control terminals, and this is the indicator terminal. How can you differentiate between control terminal and indicator terminal on the block diagram? There are two ways to differentiate. One is the if the arrow is leaving if arrow is showing the data is leaving the terminal, here the data is leaving the terminal, so these are called control terminals. And if the arrow is showing the data is entering the terminal, so if the arrow is the data enters the terminal, then it is called indicator terminal. The second sign from where you can differentiate between control terminal and indicator terminal is that control terminals have thick borders. You see, these two have thick borders, and indicator terminal has a thin border. Here from you can identify terminals on the block diagram, that which terminal is control and which terminal is indicator. Now there are two styles, two possible options. You can see the terminals on the block diagram. One is the with icon terminal view. This is the icon terminal view of in terminals, and this is without icon terminal views. So if you see the terminal without icon, they look like this. Let me show you here. So these are terminals on the block diagram. This component is called terminal in the block diagram. When I double click it, it takes me here. So this is now without icon view of the terminal. If I right click it and I view as icon, so this is the icon view of the terminals. So icon conserve more space. So therefore, mostly it is preferred that you do not see it as an icon. This is without icon view of the terminal. All right. The other component of the block diagram is called block diagram nodes. Now basically, nodes are objects on the block diagram that have inputs and or outputs and perform operation when VI runs. They are analogous to statements, operators, functions, and subroutines in text-based programming languages. Nodes can be functions, they can be sub-VIs, express VIs, or structures. Structures are process control elements such as case structures, for loops, or while loops. Now, say suppose now this is a for loop, in and this is a block diagram. This for loop is basically block diagram node because it is a structure. This is a block diagram node. Let me show you. Now this express VI is also block diagram node. This is block diagram, and this component express VI is also called block diagram node. Now such functions express VIs, and this sub VI is also called block diagram node. So I again repeat that basically your sub VIs, express VIs, functions, structures, these all are called block diagram nodes. All right. And other is the functions or function nodes. So basically, functions or function nodes are fundamental operating elements of LabVIEW, and they do not have front panels or block diagrams. functions icons have pale yellow background. Now see this multiplication function. This is called functions, or these are called function nodes. So they have, you can see they have pale yellow background, and why they are used? Functions are basically fundamental operating elements of the LabVIEW. Now see here these are also called functions, and they have pale yellow background. If you double click it, no other VI opens. Alright, so these are called functions. And I again repeat, these are fundamental operating elements of LabVIEW. Okay. Another component of the block diagram may be the sub VI. Now this is a VI. In this VI in this block diagram there is also another VI. Another VI that we call sub VI. This is the sub VI. What is sub VI? Sub VI are the VIs that run on the block diagram of another VI. They have front panels and block diagrams. So when you open it, double click it, you come to know that it has front panel. This is its front panel. When I click Ctrl E, I get its also block diagram. So this thing should be noted that every sub VI has, if I place Ctrl T, I can see both front panel and block diagram together. This is the front panel, this is the block diagram. So this point must be noted that every sub VI is a front panel as well as block diagram when you open it. Alright. Okay. So any VI has potential to be used as a sub VI. You can use any VI as a sub VI. When you double click a sub VI, the front panel and block diagram opens. Alright. The other component of the block diagram is the icon. This is the icon. So icons are the graphical representations of the VI. Icons are graphical representation of VI. This is also icon. Alright. This is the default icon of LabVIEW. So use the icons from upper right corner of front panel. So in front panel, this upper right corner is called icon. That appears when you place the sub VI on the block diagram. Now see, this is the sub VI. When you double click it, you get another VI. Now this is the icon. When you select this icon for this sub VI, when you close it in this VI, this same icon will appear from where you can identify that what code have I written in this sub VI. So this is graphical representation of the VI. Okay. All right. Now the last thing that in front panel you see connector pane. These are called connector pins. The connector pin is the map of inputs and outputs of a VI. The connector pin terminals correspond to controls and indicators on the front panel of the VI. You cannot access the connector pin from the block diagram window. You can access them only by using front panel. Okay, alright. So when you map these inputs and outputs using connector pin, you can make a VI as a sub VI. So this point should be noted that to use a VI as a sub VI, you need to build a connector pin. Alright, let me show you. This is a sub VI. When I open it, you see these input. These are the two inputs. These are the two outputs, and they are mapped using the connector pin. And this is how you create a you make a VI as a sub VI. Later on, we will discuss in detail about this. All right. Okay. So we discussed what is block diagram. We discussed the components of the block diagram. Now we discuss what are the express VIs. Now basically express VIs are type of a sub VI that you can configure with dialog box. So it requires a minimal wiring because you can configure these express VIs with a dialog box. Let me show you. Let me show you this. Now this is the express VI. How can you identify the express VI? Icons for express VI appear on the block diagram is icon surrounded by a blue field. You see these are surrounded by a blue field. Therefore, these are called express VIs. So when I double click it, a dialog box open and you can configure the settings of this express VI by the this dialog box. Okay, alright. So every express VI has a different functionality, a specific functionality. So you can also use express VIs whenever required. Alright. Express VIs appear in three different forms. It can appear as an icon, it can appear as an expandable node, or it can be expanded node. So these are the three different appearances of your Express VI. So basically, let me show you from here. Now, when I right click it and when I click view as icon, so this is the same Express VI, but now it appears as an icon. You can view it as an icon when you want to conserve the space on the block diagram. Okay, and when I remove this check from view as icon, I see it as expandable node, and you can expand it, expand this Express VI like he, like, like this. All right. So by default, you should know this that by default, sub VI appears as icons on the block diagram and express VI appears as expandable nodes. All right. Now we discuss about wires. Wires transfer data between block diagram objects. So when you connect different components of a block diagram, you connect them with the help of wires and they transfer data between block diagram objects. A broken wire, like this is a broken wire, appears as dashed black line with a red cross in the middle. You cannot run a VI that contains a broken VI. Whenever this symbol appears, it means you cannot run the VI. You cannot execute the VI. Broken wires occur for variety of reasons, such as when you try to wire two objects with an incompatible data type, like when you connect the boolean with numeric, or when you connect numeric with a string means two different data types, you get a broken wire, and that VI cannot be executed, or that VI cannot be run. All right. So there are different wire types, common wire types. This is integer. Integer blue color shows blue wiring shows that data type is integer. Whenever there's an orange color, that means that data type is numeric, but that is floating point. And when the color is pink, you should identify in the block diagram the data type is string. And when the color is green, it means LED or vertical toggle switch or any other boolean type data is there. So green color shows the boolean. This is scalar data type. This is 1D array and this one is the 2D array. All right. Now we will discuss about context help and LabVIEW help. This is a very good facility available in LabVIEW software. Now Now you see, when I place the arrow on any object, I do not get concerned help because my context help is at this time turned off. How can you turn on the context help and what is the functionality of context help? Let us discuss. When I click help and then I click show context help, so whenever I put my arrow on any of the atom, it gives me detail about that atom. Like this is express VI. This express VI is named as elapsed time. What is the functionality of this express VI? I can come to know with the help of when my control help is on or when my context help is on. Keep track of time by indicating when a certain amount of time is elapsed. The elapsed time is the present time minus the start time that you specify. So I came to know about the functionality of this express VI with the help of context help. So now right now you can see my context help. my context help is on. All right. Or you can also turn on context help by right clicking, by pressing your keyboard Control and H, Control and H together for turning on the context help. Okay. Now say suppose I put it here, or put it here, it shows me it's a file dialog option. This can display a dialog box which you can specify the path to a file or directory. So this is about context help. This is a very good feature of LabVIEW. You can know about the different functions, different express VIs, and different functionalities of different items by turning on the express VIs, and you can know how many terminals that function has by just putting the arrow on it. Another option is that you can also go for detail help or LabVIEW help. So when you click detail help, you will you can access the help from the LabVIEW. Now this is a detailed help about file dialog express VI. So these two options are available in LabVIEW, that user can turn on context help, or user can, if user wants detail help, they can also refer to LabVIEW help or detail help. All right. You can also use examples, NI example by using NI example finder. Uh, it has hundreds of installed examples. How can you refer them? Just go to the Project Explorer, help, and find examples. Click find examples. So when you click find examples, you can get hundreds of installed LabVIEW examples to refer them for your help. These examples demonstrate how to use LabVIEW to perform a wide variety of test, measurement, control, and design tasks. Alright, so if you are interested to start any project, you may find its related project to get starting functionalities, and then you can edit that program as per your need, as per your application. So uh, LabVIEW has a very strong support community available, as well as there are this NI example finder is also a very good help available for beginners and as well as for advanced users of LabVIEW. All right. Now we start our exercise. Exercise 1 1. All right. For this, you should have participant guide with you. Okay. In this exercise, we will explore a VI. As a class, identify the parts of an existing VI. Okay. You received a VI from an employee that takes the seconds until a plane arrives at an airport and converts the time into combination of hours, minutes, and seconds. Simply, this means that an airplane is arriving at the airport, and you get time in the form of seconds, and you have to convert those seconds in the format of hours, minutes, and seconds. You must evaluate this VR to see if it works as expected and can display the remaining time until the plane arrives. Alright, now you have to open flight delay the LabVIEW project in the exercise LabVIEW Core 1 exploring a VI directory. Exercise Core 1 and flight delays flight delays LabVIEW project, and from here you have to open exploring a second breakdown VI. Alright. Now on this front panel, identify you should identify the following items. How many of you can find each of them? Controls. So can you identify control in this controls in this front panel? Yes, you should identify because you have already studied. There is only one control, and this is the control, total time in seconds. Why it is control? This is numeric control because user can user should give time in seconds. That time in seconds needs to be converted into hours, minutes, and seconds format. So this is where from user will enter the data. So this is controls. This is control, numeric control. All right, and indicators. All right. So let's search for indicators. Now, how many indicators you find here in this front panel? Okay, the answer is there are 5 indicators. Hours is a numeric indicator, minutes is a numeric indicator, seconds numeric indicator. This warning LED is a boolean indicator. This message is a string indicator. So there are 5 indicators in this front panel window. All right. Now what is next? Next is, do you find run button? Where do you find run button? Basically, this is the run button. This is the run button. Where can you find? Where can you find a connector pin? So here, this is the connector pin on the front panel window where you can map inputs and outputs. Okay, where do you find icon in this front panel window? This is the icon. This is the icon graphical representation of a VI on this front panel. All right. Okay. And do you find free labels anywhere in the front panel? This is the free label that you find on the front panel window. All right. Now let's move ahead. It says press Ctrl T to view the front panel and block diagram at the same time, or select window tile up, tile up and down, or window tile left and right. So see here. Now when I press Ctrl T, I see both front panel and block diagrams together. Or you can also enable this option from window tile up and down. This is tile left and right. Right now this is tile left and right, and when I click tile left and down, the block diagram is down and front panel is up. Again see, when I click tile left and right, then front panel is left, and this is block diagram right, left right combination. All right. So on the block diagram, identify the following atoms. How many of you can find each of them? Now let's see on the block diagram. Okay, can you identify free labels in this block diagram? Where are the free labels? Yes, these are the free labels. These are the free labels. What is the functionality of free labels? In free labels, you define your algorithm, you discuss your algorithm, so that a new student or anyone who opens your code, he or she should understand your code, functionality of your code. So you write the description of your code with the help of free labels. Okay, how many of control terminals are available on this block diagram? Yes, please. Okay, this is the control terminals. This is the control terminals available on the block diagram. Control time in seconds. How many of indicator terminals are available on block diagram? 1, 2, 3, 4, 5. These are 5 indicators or indicator terminals available in the block diagram. Can you can you find out a string constant in this block diagram? Yes, this is the string constant. Here you write string. These are the ASCII characters. So these are called string constants in LabVIEW programming. Can you find numeric constants in block diagram? Yes, this is the numeric constant. This is the numeric constant. So these are two numeric constants. This 60 is also numeric constant in your block diagram. So this is how you identify components of a front panel and components of a block diagram. Now let us test our code. Say suppose I enter 3600 seconds. Now you know that 3600 seconds is equal to 1 hour. Alright. When I run it, I see it's a 1 hour and warning shows that delay is greater than 1 hour or longer. Because in the code it has been mentioned that if the time exceeds or is equal to 1 hour, then warning should be activated and it should show delay 1 hour or longer. And when I give it 60 seconds, so 60 seconds is equal to 1 minute. So warning should be deactivated as the delay is less than 1 hour. You can see here, and 60 seconds is equal to 1 minute. When I make it 3665, it means it is equal to 1 hour, 1 minute and 5 seconds, and delay is greater than 1 hour or longer. So this was about exercise 1-1. All right. So you can also see the solution. You can also see the solution in participant guide. Okay, before coming to the solution, uh, one thing more I want to discuss. You can also use you should also know that how to use context help in this exercise. So say suppose this is the this is a block diagram. Right now context help is off. When I turn on context help and I put it on this quotient and remainder function, so it tells me what is the functionality of this quotient and remainder function. It computes the integer quotient and the remainder of the inputs. This function rounds floor x over y to the nearest integer towards infinity. So this is the functionality of quotient and remainder. So when I click it on any object, I get details of that object. This is called context help. All right. And when you click LabVIEW help or detail help, you get detail help about that function. So this is a detail help or LabVIEW help about this function greater than or is equal to. All right. Now finally, one last thing that I want to add from my side in this exercise 1-1. Now what if you are called to write this code by yourself? So let us try and write this code. Let us write this code. You received a VI from an employee. This is not from LabVIEW Core 1 participant guide, but I add this exercise from my side. You received a VI from an employee that takes seconds until a plane arrives at an airport and converts the time into combination of hours, minutes, and seconds. You must evaluate this by VI, see if it works as expected and can display the remaining time until the plane arrives. So let us write this VI. I go to file, I go to new VI, I press Ctrl T. Now I need to pick up one numeric control and I should name it total time in seconds because user has to give time in seconds. So let us write total time in seconds. Alright. And now this total time in seconds should be converted into format of hours, minutes and seconds. So I need to take three indicators. I press Ctrl and drag it. Now this should be hours. This should be minutes. This should be seconds. Okay. I should have one LED to show whenever the hours exceed 1 hour is equal to or greater than 1 hour. So that warning should be shown on the LED. LED should be on whenever hour exceeds 1 hour more than 1 hour. Okay, let's drag it and make it a little larger, this LED. Okay, this is warning, and other is I need to pick one string indicator to show to show that warning. Let's it should show message that whether the whether the airport will reach after 1 hour, or the delay is less than 1 hour, or the delay is greater than 1 hour. Now after setting this front panel, I should write graphical source code in the block diagram window. So I go to the block diagram window here. All right, I turn on context help. Okay, now I need to pick one quotient and remainder function to convert this time in seconds into hour and minutes and seconds. This should be in numeric quotient and remainder function, and then I should divide this input total time in seconds divide by, I should create a constant at the second terminal and make it 3600. So this is 3600. So total time will be divided by 3600, and if the quotient is this, now quotient will be the hours, because in 1 hour there are 3600 seconds, and the remainder should be given to another same quotient and remainder function. And now this should be divided by 60, because in 1 minute there are 60 seconds. So now this quotient should be given to minutes, and the remainder will be our seconds. This is how we converted total time in seconds into hours, minutes, and seconds. Now when the hours exceed more than or is equal to 1 hour, I go to comparison palette and I select greater than or equal to. Now when hours exceed or is equal to 1 hour, I create a constant at the second terminal. I make it 1. Then what should happen? Then this LED, warning LED, should glow if the hour is greater than or is equal to 1 hour. Alright. Alright. I should also pick one select terminal. Now this select terminal, what is the functionality of this select terminal? This returns the value wired to the T input or F input depending on the value of S. If S is true, this function returns the value wired to T. If S is false, this function returns the value wired to F. Now this is the condition terminal. I connect this condition terminal here to this condition, that if the hour is greater than 1, then upper one terminal will execute. And here I pick one constant. I pick one string constant. I pick here one string constant, and if now if this delay is greater than 1 hour, then this string constant should show me that delay 1 hour or longer. Delays of 1 hour or longer. I copy it here, control and drag it, and I place the second terminal. And if this condition is wrong, false, then the bottom input should be shown, and this should show delay of delays of less than 1 hour. So delay is less than 1 hour, and I connect this output with this message to show the output on this string indicator. Alright, now my code is ready. Now let us test our code. I enter here total time in 3600 seconds. 3600 seconds means 1 hour. So LED should glow and this will show that delay is 1 hour or longer. Now let us run it. Yes, the code is working as per our criteria. Let's make it 3665. So this will be 1 hour, 1 minute and 5 seconds. Alright, now let us make it 60 seconds. This should be equal to 1 minute and delay should be less than 1 hour. So the code is working as our functionality. Now, this was the second part of lesson 1. We will continue in our next video, third part of the lesson 1. Thank you very much for joining us.